All right, guys, we're here with the countdown series. Once again, we're countdown to STAAR for series one, page five, number five. So we're on the last problem of this page. So let's go ahead and get into it and knock it on out. So point P is located at -2, 3 on a coordinate grid. Point P is translated 7 units right and 6 units down to make point P prime. Which of these is closest to the distance between points P and P prime? Okay, so here's what we want to do. First, we got to be able to get P on the actual grid itself. So what I want to do is I want to make sure my axes are labeled. So I've got positive X, so negative X will be on the opposite side. I got positive Y is at the top, so negative Y will be down here at the bottom. So now those are the directions in which I want to take. Okay, so I'm also going to label my coordinate point. Here's X and here's Y up here as well. So what I'm going to do is I'm going to go to -2, +3. So -2, +3 is located right there. And I'm going to go ahead and drop that as point P. All right. So translating something, I'm going to look at the key thing right there. SL means it's sliding. So I'm literally just going to take this and move it left or right, up or down, based off of what it tells me. So it says that point P is going to be translated sliding, or it's going to be slid 7 units right and 6 units down. So all I'm going to do here is I'm going to count 7 units right and 6 units down from that point. So 1, 2, 3, 4, 5, 6, 7. So I've got 7 units right there. 1, 2, 3, 4, 5, 6, 7 units. And then what I'm going to do is it says I'm going to go 6 units down. Okay, 6 units down. All right. So if I'm going to go down 1, 2, oops, sorry, a little sloppy of me. 1, 2, 3, 4, 5, 6. So that's where we're going to be hanging out there. So 1, 2, 3, 4, 5, and 6 will be located right here. So that's point P prime. Now it says approximately what is the closest, what's the unit distance between these 2 points? So what I have to figure out is, okay, this is 6. Now what I have to do is figure out, well, how do they connect to each other? I need to find out the distance between this guy and that guy. Uh-oh, I think I recognize what this is now. Looks like it's a good old Pythagorean theorem question. So I'm going to go ahead and drop my angle in there, point across. So it seems that I'm looking for C here. So in order to do that, I'm going to go back to my formula chart and I'm going to look up the formula for the Pythagorean theorem. So as I'm going ahead and doing that, my Pythagorean theorem, a squared plus b squared is equal to c squared. So I'm going to be using that formula. Now, let's go ahead and write that formula in. So a squared plus b squared is equal to c squared. And I can go ahead and fill the formula in with the numbers given to me. 6 squared plus 7 squared is equal to c squared. Now, here's the trick here. Once I plug this into the calculator, I can't plug this guy in because I don't know what C is. So what I'm actually going to have to do here is actually get what 6 squared plus 7 squared actually is in the calculator. So when I put that into the calculator, I got 6 squared plus 7 squared. That's 85. So I know that 85 is going to equal c squared. The last step that I have to take here is I have to take the square root of both sides to approximate that distance. So I'm going to take second x squared. That's going to give me my square root. So I don't want the square root. I want to hit second x squared. And I'm going to put in 85. Enter. That says 9.2. Remember, it says the closest to the unit distance. So 9.2 is very close to 9. So we say that 9 is equal to C. So that is how you want to solve a problem like that. So notice it has multiple elements of multiple problems.